These notes are for the notes that follow the worksheet 1 notes. So what burns? A wide variety of substances can burn or combust. Solids would include wood, coal, paper, nickel, magnesium. Liquids, ethanol, methanol, kerosene, octane, tend to be alcohols. Gases, hydrogen. Some things do not burn. Most ionic compounds, table salt, iron 3 oxide. Other examples, sand, water. So what is combustion? Combustion is the process of oxygen gas reacting with a substance to produce energy in the form of light and heat. Metals tend to form metal oxides. When they react, they produce light and heat but no flame. And hydrocarbons form CO2 and water, or CO and water, complete or incomplete, a clean burn or a dirty burn. Calorimetry is the science of measuring the energy released or absorbed in a chemical reaction or a physical change. Chemists and nutritionists use bomb calorimeters to determine the calorie content of combustible materials. How does it work? A sample in the reaction is put in the reaction chamber and is ignited by electrical energy. Think micromole rockets. The reaction takes place and energy is released. The surrounding water absorbs the heat energy. If you know the amount of water and the temperature change, you can calculate the amount of heat transferred. Heats of reactions. The amount of energy transferred during a chemical reaction. The symbol is delta H. The H really stands for enthalpy. Exothermic reactions are negative H. Energy is released. Endothermic reactions are a positive H. Energy is absorbed. So in this reaction, where this looks like methanol is combusted to make carbon dioxide and water, it releases negative 5,400 calories per gram. In this reaction, we get a negative 7,100 calories per gram. This is the combustion of ethanol. So you actually get more energy released from the combustion of ethanol than you do from methanol. Table of heats of reaction. You could look that up in an index. What do these numbers mean? Notice that the H2 gas releases the most energy per gram, not per mole though, because of the lower molar mass. The larger the negative number indicates that more energy is released per gram. Hydrogen gas is used to launch the shuttle because so much energy is released for so very little mass. So these are things we're going to cover in energy. Bond breaker, bond maker. Breaking bonds takes an absorption of energy. It's endothermic. Making bonds actually releases energy. It's exothermic. So there are some bond energies in kilojoules per mole. Bond energy is considered a measure of the strength of the bond. A bigger number indicates a stronger bond. Activation energy is the energy necessary to get a reaction started. The gas in a car will not combust unless there is a spark. To break water into hydrogen gas and oxygen gas, you need an input of energy. Reversible reactions. If a reaction is exothermic in the forward direction, it'll be endothermic in the reverse direction. So if we flip it, you get a positive number. Some reactions run to completion. Some reactions are reversible, meaning that they can make reactants after products have been made. How fast is that reaction? Some reactions happen quickly and dramatically when water and oxygen gas combine. Hydrogen oxygen gas combine. Some reactions happen slowly, the process of rusting. For a reaction to occur, the reactant particles must collide in a specific orientation with enough energy. So what affects reaction rates? Surface area, mixing, temperature, concentration or pressure, and energy. Surface area. The larger the surface area, the more quickly the reaction takes place. Mixing. When reactants are mixed well, the reaction rate increases. There's an increased probability that the appropriate molecules will collide. Temperature. With an increased temperature, the molecules are moving faster. With more kinetic energy, there's a greater probability the molecules will collide. Concentration or pressure. An increase in concentration usually speeds up a reaction to do the larger possibility of more collisions. Greater pressure will increase collisions, and energy, adding energy, radiation, or light, can increase reaction rates. Catalysts. They are substances that increase the rate of a reaction without being consumed or permanently changed in the reaction. Catalysts lower the amount of energy to begin a reaction. There are catalysts involved in digestion. Those are the end of our notes, but there is no worksheet.